this fall 2nd. My name is Hannah Whitman. I'm a faculty member jointly appointed here in IRES and also in the Faculty of Land and Food Systems. And I've had the pleasure of working with Lucas over the last several years, along with a couple of other of us in IRES, Claire Kremen. So I'd first just like to acknowledge that we are listening to Lucas and gathering here today on the traditional, ancestral, and unceded territories of the Hunkaminam-speaking Musqueam people. It's a privilege to learn on these lands. This space, this physical space that we're in on Point Grey, has been a traditional place for learning for the Musqueam people, and we have the opportunity through all of our engagements in our programs to learn from each other and from the land. I really appreciate the chance to bring those connections of learning all the way to southern Argentina, where Lucas is at the moment. I had the privilege of visiting Lucas's space last December, and we were able to see just a very vivid landscape of southern Argentina, mountains, lakes, diversified agriculture. And it was just a real pleasure to be able to compare our experiences. So I'll give the formal introduction. So Dr. Lucas Garibaldi is an eminent scholar. He is the director of the Institute of Natural Resources, Agroecology, and Rural Development at the University of the Rio Negro, Argentina, which is in San Carlos de Bariloche, Patagonia. He has degrees in agricultural engineering, and he has focused his entire career on understanding the various ecological and increasingly social dynamics of agroecology, pollination, and nature's contribution to people. He does a lot of work with farmers directly. He also does a lot of work from the very small scale up to all the global scale with different kinds of data analysis and collaborations that he's worked on, including with our the Think project that Claire and the Marabi led, where we have a number of comparative case studies of agricultural diversification globally. Finally, Dr. Garibaldi has worked as a coordinating lead author and scientific advisor for a number of international organizations, including the FAO and IBioS. And he coordinated one of the chapters in the 2016 assessment report on pollinators, pollination, and food prediction, and the 2019 global assessment report on biodiversity and ecosystem services. And in 2022, he was appointed as the co-chair of the transformative change assessment of IBioS. So we're really lucky to get to hear about his research today, and I would like to welcome Lucas and just hand it over to him. So thank you so much.
Thank you, Hannah. I'm very happy to be with you virtually. I'm sorry I had to cancel my trip to Canada, but my mom was at the hospital and the whole family was sick, so I had no choice. So today I'm going to talk specifically about some work we have been developing during the last 6 years with farmers from Argentina, directly with the farmers, particular with in this case, with the medium to large holdings of extensive agriculture, basically crops, maize, soybean, sunflower, wheat, sorghum, etc. And how we have been working with them to try to provide some data and knowledge on how to optimize agricultural landscapes, to enhance yields and sustainability through ecological intensification. Basically, all the data that I'm going to show comes from the field, not from experiments. So it's not kind of manipulative, it's observational or mensurative. And all the information that I'm going to present comes from the producers directly, from the farmers directly. And they were the ones that who collected the data. We added some data to the one they collected about satellite information, etc. But we can say that the whole information and that we are going to present is kind of a citizen science project or farming science project. And it is also important because it is a process that is going on in a way in which the scientific information is part of the decision-making system and management of production systems. So they are not gathering nowadays, they are not gathering data for a scientific project particularly. They are gathering data for themselves to improve their management and their production systems. And in that way, we are part of it. And we learn together and we develop knowledge together. So many of the questions comes from them, others from us, and the final questions are kind of interactive work that we have been doing during the past years. This is our group of research that, of course, first I want to thank to all of them that without them, all the results that I'm going to show wouldn't happen. So the project is called that, and it is a collaborative digitalization project that brings together the CREA movement plots in an homogeneous and standardized database. And this is the kind of questions that we have been asking to the database that we have been co-developing. We have been cleaning the database together, gathering data together, thinking our questions together. So these type of questions are, for example, is it possible to think about ecological intensification in extensive farming in Argentina? What impact can habitat management and landscape biodiversity have on yields? Can ecological intensification improve the financial results of the producer by reducing the use of external inputs? Nowadays, when we started, it was kind of a very basic protocol, and through time, the protocol have been improved in how we collect the data and store the data of the CREA movement in a database that is homogeneous and traceable, and how we are doing that in a way that we don't have to kind of clean all the time different kinds of data. So nowadays we have 27 campaigns. This is 27 years, but in the northern hemispheres, you're luckier because you productive season is within 1 year. So you can say, okay, this year, but we always need to name 2 years because our spring and summer comes in between of 2 years. So that's why we say campaigns. And if we say a particular campaign, we need to name the two consecutive years. So it covers around 23 million hectares. It represents 23 million hectares. And especially as data points, we have 365,000 cases plots over 27 years of around almost 2,000 companies. So there are a lot of companies, farming companies, but they are not so much or so many given the number of cases and hectares. So this is mostly social movements related to kind of middle to big farming companies. And these kind of companies, they kind of harvest or they sown around 30 million hectares in Argentina. So 30 million hectares of crops is larger than the area of the UK, for example. So this is a huge area that we are working and that we can influence decision-making through science. And for example, the database nowadays has more than 300 operating variables of different aspects of the production in each plot, from management aspects to to environmental aspect, to weather aspect, to, well, there are a lot of variables, and I will show you some of them. Of course, this is kind of an incomplete data set. So according to the question that we have, we perform different subsets of the data sets that are adequate to answer each question. So this is a unique database in the sector, in the agricultural sector, because its main purpose is to perform research, but also to improve management. And it is crafted by the same producers and technical advisors of the producent. And it's collaborative and inclusive. So I provide my data and I receive information from the data of other producers. So, and it's really important that the owners of the data are the same farmers. So this is quite unique. Usually nowadays, the data is really important and really valuable, but we don't own even our own data, our own personal data. And so this is very special of this kind of data set. And it requires a lot of effort, and the CREA movement maintain this effort, and they are kind of excited about this, and to transform from the data information that we can use to take better decisions. So I will briefly talk about 4 papers that we have developed from this database, and a 5th one that is going to be submitted soon. And in some of the papers, farmers or people from the movement are also co-authors, and we met regularly with them. So the models that we are trying to use in our case is with the purpose to enhance the understanding of biodiversity roles at various scales, particularly at the land scale level in agricultural production. So basically, our models can predict yield or different aspects, and one of the papers is more focused on prediction. But basically, what we wanted to do is to focus on the environmental dimension of the production and how we can improve both the environment and the production dimensions altogether. And how we can create synergy between productivity and biodiversity. So our models, I am not going to show you much about now machine learning models, because our main objective was to understand, and that understanding improves our management. So from that side, we use other type of models that are more suitable for those purposes. We have tried many different models, but these ones so far, the ones that work the best. So the first information that I'm going to show you is not temporal, but only in 1 year. So it is spatial comparisons. And then through the end of my talk, I am going to focus a little bit more on temporal comparisons. And now we are working on full time series, but I'm not going to show you about that. And that also reflects a little bit the process of developing this database. So at the beginning, we didn't have many years, so they were not good enough in data to understand temporal trends. But now, after creating some synergy that people show the results are useful, they can implement them. So they are more engaged in gathering more data. And now we have kind of time series, and we are working also with time series. But for now, I am not going to show you anything about that. So one of the dimensions that we focus on was on weeds. There are huge problems with weeds. Here you can see the amount of pesticides that in kilograms per hectare that we have been using in the agricultural sector. And you can see that it's not very sustainable. So we need, through time, more and more pesticides per hectare to obtain more or less the same productivity. So farmers see this and they need to pay a lot for the pesticides, and this is a huge problem. The increasing use of inputs in the agricultural sector. And not surprisingly, many insects and weeds are becoming resistant to this pesticide, even insects that disperse very important diseases in Latin America. And here you have the number of weeds in the left through time that have become resistant to glyphosate. And you can see that there is an increasing trend. And on the right graph, you can see the number of weeds that are becoming resistant to the different type of herbicides. So basically, the farmers are using more herbicides, more pesticides, but the weeds are not dying because they are becoming resistant. So this is a very important problem nowadays, especially in extensive farming. So here are some of our results from Argentina, as I show you. So on the left, you see the data points. We have in this analysis around 10,000 fields for maize and for soybean. And you can see the distribution in Argentina. So that area again covers around more or less 30 million hectares. So it's big. And what we are trying to see here is what is the influence of habitat restoration at the landscape level and habitat complexity, we can say. And for that, we use a simple index that is called edge density that you can see at the bottom of the graph. And you can see that from left to right, the edge density increase. That means that you move from homogeneous landscapes on the left to more complex landscapes on the right, more diverse landscapes on the right. And this edge density, you can calculate edge density in many different ways. But here, we counted the length of the neighboring neighboring habitats between the crop and the natural or semi-natural areas. So if you have two crop areas, one next to each other, that it didn't matter for our edge density calculation. So this edge density is the length of the perimeter, but only considering crops versus natural or semi-natural areas. So we wanted to see really the influence of the natural and semi-natural areas nearby on the weed on the weeds. So now if we move to the two graphs, you can see that for maize and for soybean, the proportion of herbicide-resistant weeds decrease 3 times with edge density. And this is really important. So you move almost from fields in landscapes that are very homogeneous, that have around almost 40% of the weeds are resistant to herbicides, to landscapes that are a little bit more diverse. For example, 60 meters per hectare of edge density is not so much 60 meters per hectare. And these landscapes that are more diverse, they have on average 10% of weeds that are resistant to herbicides. So this graph has been very well received by the farmers, and they are very interested about this, and they are trying to think, okay, how the landscape is influencing the dispersion of weed resistance and why this is happening and why the effects are so big. And we can discuss more about this after my talk is finished when we have time for questions. But this is really an impressive result. So of course, the analysis account for many covariables that could confound our effects. So with the trend with many management variables like fertilization, the variety, etc. And we make many different tests in a way that our results are not so biased. And we can discuss also more about this. And this is the prevalence of different weeds in the different maize and soybean fields, and we can talk also later about that. Then we focus also on inputs, on fertilization. So we are trying to cope with the different parts of the profit equation and the environmental equation, right? The cost, economic cost in weeds and fertilization, but not only economic, but also environmental. And also later we are going to talk about the income, the productivity of the crops. And here we focus a little bit more about some social aspects in terms of the tenure regime. And you can see that our farming system has a high prevalence of companies that rent the land. So, and so there you have the different percentage. And you can see that sometimes in many places you have half from half of the land that is sown, it's performed by the farmer on its own land, and the other half it's performed by a farming company or a farmer on a land that is rent, that is not owned. So we hypothesize that tenants maybe they are going to perform some management practices that are not so sustainable in comparison to the owners. And in terms of the application of the fertilizers. And here you can see for maize on the left, soybean on the right, the nitrogen applied on the top, phosphorus applied on the middle, and sulfur applied on the bottom. And then you have kind of the environmental potential of the land. And the most obvious trend is that when the land is more productive, they can harvest more. They are going to fertilize more the land because they are going to obtain more harvest. That's the first trend, and it happens with all the nutrients and in all the crops. And the difference in the colors between the blue and the orange and tenant or owner. And we did not find much difference between the tenant and the owner, except on the phosphorus application. And you can see that on the phosphorus application, the trend was kind of what we expect, that the owners, they apply more phosphorus in a way to return more the nutrients that they take out when harvesting to the land. And the tenant, they don't do so much. And this is probably because the phosphorus has a kind of a longer term cycle, and when you add phosphorus to the soil, you are improving the soil in the long term also, not only in the short term. In contrast to some nitrogen fertilizers that when you apply them, you know that all that nitrogen or most of it is going to come back in your harvest. So we find some difference as expected, but we did not find so many difference. And this is partly related because conventional agriculture is a kind of a simple and homogeneous package, technological package that all the farmers apply in similar way, irrespective if they are the owners or the tenants of the land. And here we can see the balance of nutrients. On the left, you can see again for tenant and owners, and you can see that it's mostly the same. And you can see the balance for nitrogen, phosphorus, and sulfur. And you can see that for nitrogen and phosphorus, we have a negative balance. So the agricultures in the Pampas is kind of a mining system where every year we take out more nutrients that we put, and those nutrients go to China or different places in the world, and they never come back. So it's kind of a mining system in terms of fertilization. For sulfur, it does not happen that, but this is because sulfur also is part of other compounds that farmers apply to the soil. And on the right side, the graph, you can see the same, but now the different colors are the environmental potential, so low, medium, and high. And before I told you that in places with high environmental potential, the farmers apply more fertilizers, but they also harvest more. And the balance is even more negative. So in high potential size, they apply more fertilizers, but they harvest more. So the balance is even more negative. So this is quite important also. And this comes all from their own data. So this is kind of information that we can use to take decisions. So then we focus on productivity, on the harvest. And here you have 500 fields from the main sunflowers areas of Argentina. Argentina is one of the main sunflowers producers and exporters of the world. And again, we have edge density, and from left to right, edge density increase. So on the right, we have more kind of habitat diversity or complexity. And we can see the first graph that we can see that on the left, that sunflower yield, sunflower productivity increase with the edge density and increase by a lot, on average 24%. So this information comes from the harvesting machines of the farmers. So this is real data. So the sunflower fields that are in landscapes that are more diverse, they harvest almost 25% more than those sunflower fields that they are in landscape that are more homogeneous. And later, again, we can discuss about why is that or the mechanism. And another way to see a similar pattern is on the right graph, where we have field size. So during the past decades, we can say that almost in every place in the world, the field size become larger. The plots of the farmers are becoming larger, so to allow larger machines, and this is more efficient in terms of labor and in other aspects of of the production function. However, this pattern or this trend, when the farmers want to do this or the companies force them to do this, does not take into account ecology. And you lose a lot of environmental services. And here you have this paradox when the larger fields, they harvest less. And again, the magnitude is huge. So in average, 12% less of harvest in larger fields with respect to smaller fields. So this is quite impressive.
About 5 minutes remaining, Lucas.
Sorry? Sorry, can you repeat?
4 minutes remaining for the top
Okay.
one.
Yeah, thanks. So again, the different covariables, I will move a little bit faster now. Then we move again to soybean and maize in terms of we analyze many variables of the environment management, of course, the landscape, to predict crop yield. And we find very good models to predict soybean yield and to predict corn yield. And we can discuss some of these patterns later. Here we did not find a huge effect of the natural habitats, but maybe because there was a pattern at the national scale of correlation between natural habitats and other management variables. So we could not determine here the effects of the natural habitats. But in general, we did not find any negative effects in any of our studies. And this is the last study that I wanted to show you. Now we start with some temporal series, but we have longer time series that I'm not showing data right now. But in this time series, we focus on the crop rotation during 5 years. And we analyze the effects of the 5 previous years on the following year. And in particular, we wanted to understand the effects of the diversity of crops in the previous 5 years and how that influenced your productivity and your environmental impact on the next year. So you can see that some rotations were of very low diversity, only 2 crops during 5 years, and others were of higher diversity. When we say higher diversity in this context, it's never more than 6 crops as maximum in 5 years, and that's a lot. So, so it's not a huge diversity. And we wanted to understand the effects on 2 contrasted years. One year that had a normal season and another year that was a dry season. So how the diversity of the previous crop rotation can influence your outcome in a normal year in terms of precipitation or in a dry year. And these results are also quite impressive. We have maize on the top and soybean on the bottom. And the left column is the environmental impact quotient. Is kind of an index that we take from the amount of agrochemicals that they use and the toxicity of each of these agrochemicals. And you can see that in both cases, in maize and soybean, from left to right, when you increase the diversity of the crop rotation, the environmental impact decrease. So this is quite good. And if we now focus on the top right, we can focus on maize. And you can see that the blue line is for the normal year and the orange line is for the dry year. And you can see that the diversity of the crop rotation doesn't have an effect on a normal year, even negative or positive. But in a dry year, the effect of the diversity is quite positive. And you can obtain the same crop productivity in a dry year as in a normal year if you have more diversity of crop rotation. So this is a clear example of how diversity increases resilience in the real world and in agriculture. So it's quite impressive. And soybean did not respond to diversity. It did respond quite impressively to dry and wet years, we can say. And this is the same for cover crops. Cover crops are one of the variables that increase diversity. We can focus a little bit on the left, that is again the environmental impact, and we can see that when you have cover crops, you use less agrochemicals. And on the right, we did not see any important effects of cover crops on the crop productivity. And that's quite good because it might happen that in dry years, if you have cover crops, they take out all the water and then you harvest less. So basically, they reduce the environmental impact, but they don't have a huge impact on crop productivity. And this is the final graph. You can see here that also diversity, the effects of diversity interact with the nitrogen fertilization. So if we go to normal years, the effects of diversity are only evident in the orange line. So when you have low nitrogen fertilization, but if you fertilize a lot, so you erase the benefits of the diversity. And in the dry years, the diversity increased crop productivity irrespective of fertilization. So again, this is a quite impressive result, and probably from a book about how you can provide services from inputs, an input-based agriculture or a diversity-based agriculture, and how the diversity-based agriculture is useful in normal years because you obtain the same crop yield, but it gives you advantages in dry years. And so then we are focused also now in the quality of the crops. We have data on that, and we have been adding a lot of maps to this database to ask me questions about different dimensions. And as I told you before, we're also exploring different questions through time series to understand trends for the last almost 30 years in the agriculture in Argentina. Okay, thank you. So with HANA, we are working with Light Farm database, and that's more focused on smallholders family farms and has a great emphasis on on nutrition, on human dimensions, and we are trying to do also a similar track in terms of trying to discover new things from the database.
Hey, is that working? Can you hear me?
Yeah. Yes.
Okay. Thank you for the presentation. It's very interesting and it's a large data set to, it's rather impressive. It's more than 20 years of research and data collection. I want to ask a question about the diversity in the farms. I can imagine the farms you're looking at are commercial farms, large scale. Is that the reason why you look at crop rotations in terms of diversity instead of the crops they're planting in a year in a farm? Because I'm wondering, like, if the crop diversity the farmers planted in a year would have an impact on climate resilience, for example.
Yeah, these are large-scale commercial farms. That is the most common things in terms of area in Latin America. And they are not very diverse. So yeah. So we are trying also to understand the value of diversity and to increase diversity. And the farmers, in general, if they see it, they respond quite fast. So for example, the area with cover crops had increased exponentially during the last 5 years in Argentina as a way to reduce the amount of agrochemicals and also to increase the diversity and many benefits.
Thanks, Lucas. That was amazing. I have a specific question. I was talking to some farmers in the US, commercial farmers, large scale, about cover crops. And they were arguing that they can't use cover crops because it takes up too much water for their subsequent crop. So I was wondering if sort of water availability has been discussed regarding whether farmers choose to use a cover crop or not in that context, or is water an issue for those systems?
Well, in our system, it seems that it's not an issue because we did not find the negative effects of cover crops in the dry season. And the dry season was really dry. So it was like 50% of the precipitation, half of the normal precipitation. So of course you need to learn how to manage cover crops, and it's not everywhere the same. It depends when it's rain, how it's. So not only on the amount of rain, but also when is the cover crop happening and when is the rain happening. So there is no universal response, but in general, it doesn't seem a huge problem in this large area of the world.
Hi, Lucas. Claire here.
Hi.
Really nice to hear your talk. It's really, really fascinating. I remember a conversation that we had, oh, I don't know, maybe a year ago or so, where you were telling a little bit about how news was spreading among the farmers about the work that you're doing and working with them on, actually planning in some of these restored areas. And I was really kind of amazed because in my experience in North America, I don't see so much farmers coming to us and saying, we want to do this. And so both that part and also just joining this citizen science data collection effort, I think it'd be really interesting for everyone here to learn a little bit more from your perspective of how this has evolved, how it's come to be, and how the knowledge is kind of being shared among the farmers.
Yeah. Hi, Claire. Nice to hear you. I cannot see you, but yeah. So tomorrow I have another talk, and I'm going to talk about specifically those examples of how we are restoring the land. And basically, we, as a research group, we started ourselves to restore the land because we interacted with the farmers, we discussed information, but then nobody knew how to do it. So we started with them, what we can say, kind of redesigning their complete farms. And so redesigning the fields, changing the way that they sow, and taking land out of production, and sowing biological corridors. And we started 1 year ago, and in 1 year we restored 15,000 hectares. And that's more or less 10 farms. So these are big farms of all. Some of them are more than 2,000 hectares, others are less than 500 hectares. Now we are working in one farm of very small farm in Paraguay, 20 hectares. But this, now we are working with the farmers that they are the ones that are more kind of innovative. They are eager to risk things, and this is a huge risk for them, and they are paying for it also because they are changing everything, and they are really convinced, and things are going well so far. And most of them, they are not so worried about increasing productivity, the amount of harvest. They don't want to lose productivity, of course, but they are seeing. So these farmers, they have different motivations. Some of them are too old, so they want to leave to their kids, to the grandsons, something different. So they want to do it. Other ones, it's kind of, so the sons are coming into the farm and they come with another mind and they want to do things differently. They don't want to follow the ways that their parents do their things. So we have some people that is motivated by that. Other people see that the current system is not working and that they are using a lot of inputs to obtain the same harvest, and they see the degradation. They don't tell it to the public, but they see it on their lands. And they also see the market opportunity. And it's people that is also eager to change and want to learn different things. And yeah, and they also see the social pressure on them, because for example, in Argentina, believe it or not, but 70% of the national income comes from agriculture, 70%. So almost all of our income comes from soybean, maize, and cows. And so farming themselves thinks, okay, we should be the heroes, but everybody hates us because of the agrochemicals. So we need to change this in a way. And so some people are also motivated by the social pressure and trying to change the way people look at them. And also, many people see that the markets are changing. Now we cannot sell soybean that comes from deforestation. But usually the motivations in Argentina doesn't come at all from the governmental processes or the state or we do have very good laws, but the regulatory force, it's almost absent. And so usually we are more influenced by the markets and the social trends, especially by the international markets, rather by our own provincial or national laws, basically that. And yeah, and tomorrow I will talk about the specific examples, how are we doing it, what are the difficulties that we are finding, and also the benefits and this kind of thing.
A question from someone on Zoom next. So Maura, do you want to go ahead?
Hi, can you hear me now?
Yes.
First of all, I would like to say that I'm a student at University of Rio Negro studying agroecology. So I've heard of your work really directly from my professors. I would like to know whether you've analyzed the, let me rephrase it in my head, level of environmental awareness the farmers had when you researched. I don't know if I phrased that correctly.
Yeah. At least I understood. We are doing some work also to gather this kind of data set with the smallholders, especially with intensive agriculture, which is what most smallholders do here in Argentina. And usually these smallholders are urban or peri-urban. They are in the cities or close to the cities. So we are trying to do the same process with the smallholders in different parts of Rio Negro. And there we work ourselves with questionnaires. And there we have some questions related to those aspects. So far we did not analyze, we don't have the database so well developed, and we did not analyze yet that kind of questions, but we plan to do it in the next few years. And Light Farm is a great project in that regard.
Thank you.
Hi, my name is Ilka. Thank you so much for your talk. It was really interesting. My question is a bit of a follow-up maybe to Claire's question. I was curious if you could just tell us a little bit more about how the data is collected. It's really cool to have such a large data set, and I'm curious how you work with the farmers, how you ensure sort of consistency between the different companies and gathering the data. Yeah, just if you could elaborate there. Thank you.
Yeah. So we have been working with the CREA movement during many years. And of course, we signed kind of confidentiality statements about the data because they're providing you all the data. So you can, from there, make all the analysis about profit that you want. And if you're the government, you can tax them or all these sensible things. So we are very serious about this trust that we have developing during the years. And we are very serious about the type of information that we give to the people. We never give a preliminary information because that could do a lot of damage. And regarding the data collection, the CREA movement is a social movement that they own 30% of the land, more or less, in Argentina. And now also many companies that are outside the CREA movement, they are bringing data into this data set because they want also to be part and to take advantage of the information. So they are very well organized into different kind of regions and locations, and you have one technical extensionist each 8 or 10 farmers. And that person, that technician, is the one that coordinates everything regionally. And this technician also gather in different type of meetings. It has 2 hierarchies. One is thematic, and the other one is spatial, kind of regional. So the technicians and the producers, they participate in different thematic meetings and also different kind of locality meetings. If you are from a region, CREA is divided in different regions. So you participate in the meetings of that region, and then you have national meetings. So it's very well organized. And they are also kind of a hub of, so Argentina is a very stable country, and they are always analyzing information all the time to survive and make money, because they live in very changing conditions very drastically from year to year with the price of the crops or the governmental conditions or the taxes or the climate. So they are very well organized, and they are eager to gather information and to use information to survive and to progress somehow. So the government tax 25% of the crop productivity to the farmers, and this is a huge income to the country. So in other countries, the government subsidy the farmers. Here is kind of the opposite. So I don't know if I explained it well or you understood. Not.
Okay, that's all the time we have today, but thank you so much, Lucas, for joining us.